Hey everybody, it's Mr. Odom here, and in this lesson I am going to cover section 8.4, areas of composite figures. This is the last section in chapter 8, so we'll be having a test in a week or so. So as usual, you will need the following tools: a pencil, composition book or notebook paper. If you want to print out the notes that go along with this section, you can do that and follow along using those notes. And that's it. So the learning target for this lesson is, at the end of it, hopefully you'll be able to say, I can find the area of a composite figure. Okay. Before we start finding areas, I thought it would be helpful if we could review some of these formulas. All right. So do you remember the formula for the area of a circle? All right, so I'm going to write it down right here. Area of a circle equals pi times the radius squared. Do you remember the formula for the area of a semicircle? That formula is the area equals pi times the radius squared, all divided by 2. What about the area of a triangle? We haven't had to probably use that one in a long time. So do you remember the formula for the area of a triangle? So that formula is area equals the base of the triangle times the height of the triangle, all divided by 2. So if I have a triangle like this would be my base, and my height, let's say this is a right triangle, this would be my height. And then the area for a rectangle, I know you guys remember that one. That's area equals the length times the width. So if I have a rectangle here, it's my rectangle, this would be my length, and this would be my width. And then the area of a square, we've used that one before. The area of a square is, it equals the side of the square. Whatever the length of the side is, you square it. So if I have a square, all 4 sides are the same length. This side length is, let's say, S. Well, all the side lengths are S. So I just take 2 of them, multiply them together. What about a parallelogram? What is the area of a parallelogram? Do you remember? So the area of a parallelogram is, I take the base of the parallelogram and I multiply it by the height of the parallelogram. Let's see if I can draw a parallelogram. There we go. Parallelogram. Okay, parallelogram. So the height of the parallelogram would be this value, and the base of the parallelogram would be this value. And last but not least, I'm sure this is one of your favorites. What is the area of a trapezoid? So the area of a trapezoid equals the height of the trapezoid times base 1 plus base 2, and that is all divided by 2. So let me draw a trapezoid here. So trapezoid is a quadrilateral with exactly 1 pair of parallel sides. So the parallel sides, one of them I will call it base 1, the other one I will call it base 2, and then the height of my parallelogram, the height of my trapezoid would be here, h. Okay, so those are some important formulas. Make sure that you have those written down somewhere where you can get to them, or keep them in your brain. Keep them in your brain. Okay, so here's an important point. To find the area of a composite figure, separate it into figures with areas you know how to find. Okay, so separate it into figures that you know how to find the areas using the formulas from above. Okay, then find the sum of those areas. So what I want to do is look at a couple problems and look at them two different ways and see if we can solve these problems two different ways. I will tell you you can solve them in many ways. So this first problem, let's find the area of the figure. So let me break this into figures that I can find the area of. So I'm going to put a line here. I should probably use black. Maybe make this a little thicker. So here is, you break that into, I've got a parallelogram up here. That's my first one. And then I have a rectangle down here. Okay, that's too thick. What about over here? Here's kind of a slick way we might be able to do this. Let me draw this vertical line. Let's say I cut this piece of the triangle off and move it so that it fits right here. So I take this piece of the triangle and I move it so it's over here. Now the shape that I have is just a rectangle. Okay? So I'll leave this one for you to find the area of that rectangle. But if you break it into two shapes, and if I want to find the area, well, the formula for the area of a parallelogram is the base times the height, plus the formula for the area of a rectangle is the length times the width. All right, so we need to find the height of my parallelogram. That looks like 1, 2, 3 units. And the base of my parallelogram is 1, 2, 3, 4, 5 units. So 5 times 3 plus the length of the rectangle, 1, 2, 3, 4, 5 units, times the width, 1, 2, 3 units. All right, well, you guys know what 5 times 3 is. So the area of this figure is 30 units. Okay, which we could have gotten from here with our rectangle. There's 1, 2, 3, 4, 5, 6 is my width. 1, 2, 3, 4, 5 is my length. Okay, let me move on and let's look at another example. And my examples are right here. They're hiding from me. There we go. Let me scoot this up. So let's find the area of these figures. Okay, so this first one, let me break this up into, there's a trapezoid, there's a rectangle, and there's a triangle. So I have 3 shapes, 1, 2, and 3. How else could we break this up? Well, what about this one? If I have a triangle, another triangle, and notice these 2 triangles are exactly the same. So if I find the area of one, just multiply by 2. Or I could cut this piece off, put it right here. So that gives me a square, and then I have a rectangle and a triangle. Okay, either way you guys break these up, do it the way that it's easiest for you. Okay, so I'm just going to go with the first one. We need to find the height of my triangle. So I'm going to move the 1 over to here. So the height of this triangle is 2 units. The base of this triangle is 4 units. So let me see. Area equals the formula for the area of a triangle plus the formula for the area of a rectangle plus the formula for the area of a trapezoid. All right. So the base of my triangle was 4. We figured that out. The height was 2. And we divide that by 2. The length of the rectangle is 4. And the width of the rectangle is 2 plus. So let's see, the height of my trapezoid. What is the height of my trapezoid? Very good. It is 2 units. And then what is base 1? What is the length of base 1 of my trapezoid? That is 1, 2, 3, 4 units. Plus base 2. What is the length of the second base of my trapezoid? Well, it's 1, 2, 3, 4, 5, 6, 7, 8. 8 units, and that is all divided by 2. So now we just have to do some math, right? Now we just have to do some math. So when you guys do the math, what do we get? I think the answer you get is 24 units. And remember, area is always squared. So the answer is 24 units squared. Okay, so then we have that problem. Let me scroll down. I think I got some more down here. I do. It's hiding from us. There we go. So let's find the area of this figure. It's not in a grid, but we can break this figure up into other shapes. So what shape should we use? How about, let's do this. So it looks like I have 3 shapes. 1 rectangle, 2 rectangles, and then 3 rectangles. Or actually 3, the shape of number 3 based on the side length. So one side is 3 feet. How long is this side? It is also 3 feet. All right, so let me do this. There we go. So I have 2 rectangles and a square. So for each rectangle, the dimensions of the rectangle, well, first let me write the formulas I'm going to use. So I'm going to find the length and width of one rectangle, the length and width of the other rectangle, and then the sides of my square multiplied together give me the area of the square. So what is the length of this side of my rectangle? What do you think? So it looks like we have to do a little math here. We know that these 2 lengths are going to be the same. We know that this side is 15 feet. But there's a little piece missing here, and that is 3 feet. So between the two of these, each one should be, if I added them together, I should get 12 feet because 15 minus 3 is 12, which makes each side here 6 feet. And I already know what the width is. The width is 8 feet for both rectangles. So I can go ahead and just say 6 times 8 plus 6 times 8. Those are the areas of my rectangles, plus 3 to the second power. So when you calculate this, you get an answer of what? The answer is 105 feet squared, because area is always squared. All right, let's look at one more, and then we'll be done looking at examples. So we need to find the area. There's another figure here somewhere. I promise. Where to go? There it is. Here we go. That's it. All right, we got it. So we need to find the area of this figure. So this is a composite figure. Most students are going to want to, because a lot of students don't like the formula for the area of a trapezoid, so they may want to make a triangle out of that. All right, which you can. The base of the triangle would be 14 centimeters, and the height of the triangle would be, well, this is 24 centimeters. This is 18 centimeters. So the height would have to be 6 centimeters. So you could do that with 3 shapes. I'm just going to do it with 2, because I like using that formula for the area of a trapezoid. So we have a semicircle. So the area of a semicircle is half the area of a circle. Pi times radius squared divided by 2. Plus, the formula for the area of a trapezoid is the height times base 1 plus base 2 divided by 2. Okay, so let's fill these numbers in. All right, so pi is 3.14 times the radius of my semicircle. Well, the diameter of my circle, which this semicircle would be part of, is 14. So my radius has to be 7. And I want to square that over 2 plus the height of my trapezoid. This number would represent the height of my trapezoid. The height is basically the distance between the parallel sides. So the height would be 14. Base 1 would be 18. Base 2 would be 24. And that is divided by 2. Okay, so in your calculators, you can go ahead and calculate the answer to this, and you should get 371 centimeters squared. Okay, so that is it for 8.4. And your assignment, you're going to get a lot of practice in finding the area of composite figures. You'll have to do it on your test. So give yourselves a hand. You guys did a really good job. That was really good. And hopefully you're feeling like a lion today. Yeah, let that roar out. And I will see you again soon. This is Mr. Odom, and I'm out.